Okay, well, thank you very much. And this is the second time I've been here. I really love this country. It is a beautiful country, a beautiful city with great food. And the best part has been just the welcome of the people here. And I've just very much appreciated the people had a chance to meet and the friendliness and warmth of the people. I just thank you very much for having me here. So today I would like to talk about some of the approaches we use for scaling up DLTs, for distributed ledger technologies, for blockchains. How do we scale them up? And we just heard some in the last talk about this. It's something that we're very interested in, but of course we want to maintain trust. The whole purpose of a DLT is to have trust. So we want to make sure that we can maintain the trust as we scale them up. And where does the trust come from? It comes from the governance, having good governance. It comes from the security that's inherent in the consensus itself, like being asynchronous, Byzantine, fault tolerant. It comes from knowing that you have validity because you have proof of work or proof of stake, something that causes you to trust the validity of the transactions, of their ordering, to make sure that it can't have double spins, those sorts of things. Fairness can increase trust. This is something that most people don't talk about. But the question is, do you ever have one computer or one person that can influence what order is the consensus, or can stop you from having your transactions go in, or can affect the timestamps? So fairness, if you have fairness of ordering and of transaction timestamps and of access, that can also increase trust. And then transparency, we want to make sure other people outside the ledger can make sure it's working. Privacy is something that public ledgers tend to not have, but you bolt it on top, or you do side things that give you privacy. These are the things that build trust. And the question is, as we scale up, can we maintain the trust? So how can we scale up? Well, the best way, of course, is you have a single mainnet and it's just very fast. For the same reason, I would rather have a computer with one core that is super fast rather than lots of cores. So to start with, of course, we want to have the single mainnet, single shard, single ledger be as fast as possible. So we try to do that. But there's always limits. There's a limit to what you can do on a single mainnet, single shard, single network. So what do you do when you want to go beyond those limits? Well, you can do sharding. Break it up into several ledgers that talk to each other and act like one big ledger. Then you can split up the work, sometimes. If your traffic pattern is bad, sharding doesn't help. But if it's good, then sharding helps a lot. Or you can have side ledgers that are more independent than simply shards in a single ledger, and they communicate less often to the main ledger. That gives you great scaling if you have the right kinds of traffic patterns. Although we have to look at how trust works in a side ledger situation. It gets more complicated then. And then there's consensus service. This is a new thing, and we're going to spend more of our time on that. We can talk about how the consensus service can give us scaling and have better trust properties. So let's go through these. The performance, the trust, the fairness, and the privacy are the four things that we want to look at for each of these approaches. Is it fast? Does it maintain the trust? Does it have fairness, if the original one had fairness? And can it maintain privacy? So we'll build a table, and we'll just go through and build this up, showing a table of all these things. For each of these four approaches, what kinds of properties do we have? Okay. So the simplest approach is you just have one shard, one network, one big thing, one single ledger, one single blockchain, one single DLT, and you just try to make it as fast as you can. Over on the right side here, these circles are the nodes of your network. They're connected to each other. That is your mainnet. That is your ledger. Every node is the same. The information is copied onto every node. The computation is done by every node. It is the same for every node. That's a single ledger, a single DLT. The faster you can make it, the better. But there are some limits. So the single source of truth is in that ledger and is on every computer. And we'll emphasize this. Where does the true information get stored? For example, in a cryptocurrency, where are the balances stored? So this picture shows you that the balance for Alice, the balance for Bob, the balance for Carol is stored on all the computers in the main ledger. Now, other people may have a copy of it, but those copies may or may not be right. The single source of truth is in the mainnet. That's what the mainnet does. Great for trust. If you can trust more than 2/3 of the nodes, you're fine. Or if it's proof of stake, if you can trust more than 2/3 of the stake, you're fine. So it's good for trust. Not so good for privacy, inherently, because it's a public ledger. Every transaction is visible to the world. All of the data stored there is visible to the world. Now, you can do tricks. You can do various encryption of things, and you can do zero-knowledge kinds of proofs, and you can do extra information. I only store a hash. I don't store my file. But the ledger itself is inherently public. It doesn't inherently give you any privacy. So we would say that just for a single mainnet, the performance is maybe good or bad, but we would like to improve it. Some mainnets are faster than others, but we'd like to make it faster regardless. Trust and fairness can be very good, and privacy is not so good. You have to build something else to give you privacy. The ledger doesn't give you privacy. And the fairness here, I'm coloring green. It depends on the ledger. Actually, very few ledgers care about privacy, about fairness. They just say, well, we'll all agree on what the order of the transactions are, but there's no guarantee that you can't have one person influencing that order too much. So maybe not so good for a stock market, but good for other things. On the other hand, some ledgers do have fairness, and then that's good. So I colored it green because some ledgers have fairness. Now, sharding is different. Now we have two circles on this screen. It's like two separate DLTs, two separate blockchains, but they coordinate very closely with each other. Now the single source of truth is split. So maybe Alice's balance is in one of the ledgers on the left, but Bob's balance is a different ledger over on the right. I'm sorry, Bob is on the same one. Carol is in a different ledger on the right. So every computer in the shard on the right knows Carol's balance, and every computer in the shard on the left knows Alice and Bob's balance. We split up the single source of truth. Again, there may be copies elsewhere, but this is the source of truth. Then transactions are a little bit more complicated. If Alice wants to transfer cryptocurrency to Bob, it just happens within that shard. It doesn't touch any other shard. Everybody else runs in parallel, so it can be very fast. Now, what if Alice wants to transfer money to Carol? Well, in that case, you have to have communication between the shards. There has to be some kind of inter-shard message from Alice's shard to Carol's shard. Alice's shard will decrement her balance. Carol's shard will increment her balance, and you need some secure communication between them that guarantees finality and that you can be ensured that Alice's balance really did go down before you bring up Carol's balance. And you also want to make sure the message doesn't get lost in the middle, where Alice decrements and Carol doesn't go up. That would be bad. So that's what we have with sharding. We have to be very careful. But if the single shard has finality and has ABFT or whatever security, then the whole sharded ledger can have finality and have ABFT and be trustworthy. If you have state proofs that prove the data coming out of any node on the single shard, then of course the other shard can believe it. So it is possible to have the whole ledger be just as trustworthy as each of the little shards. So we can have good trust, and of course privacy is the same as before. The ledger itself gives you no privacy. It's public. Everyone sees everything. And you can build on top of it to have layers of privacy, but that can be slower. So for sharding, we have maybe improved performance. Now, it's still bad if every transaction in the world always talks to Alice's account. Sharding didn't help. It made it worse. But if your transactions are very parallel, then sharding can help a lot. Very much like going from one core in a computer to many cores. For some problems, it works very well. It speeds you up very nicely. For others, it speeds you up less. Now, side ledgers are a little bit different. The single source of truth, say the balance for Alice, Bob, and Carol, is still in the mainnet. Every computer in mainnet has a copy of it. But you set up a side ledger of Alice, Bob, and Carol, a side chain, a side DLT. And for example, throughout the day, Alice, Bob, and Carol have many transactions between them, sending their cryptocurrency back and forth to each other, not touching the balances on the main ledger. And then at the end of the day, you send a summary to the main ledger to update those balances. Assuming there are many transactions off the main ledger, and then just one summary on the big main ledger, that lets you be much faster. If you can do n of them on the side ledger for every one on the main ledger, then you're n times faster. That's great. So this can be great for performance. Privacy is okay. So you still have the balances being shown to the world. You don't have the transactions during the day being shown to the world. In some cases, that's good. That's an improvement on privacy. But at the end of the day, the summary still is visible to the world. So your privacy is maybe a little bit better, but maybe not entirely as good as you would like. If you want to hide the balances and hide even the summary transactions, you have to resort to something else on top. And the trust can be worse. You do have trust that the balances on the main net are secure, but you also have to have Alice, Bob, and Carol trusting each other during the day a little bit. So that's less good. They can still do some form of cheating each other. Maybe less. Maybe they can't steal everything Alice has, but they could revert things during the day or in some ways do dishonest things during the day. It depends on how you've set up your side ledger. So there may be some degree where you have to, Alice, Bob, and Carol have to trust each other. So the trust maybe isn't as good as just a sharded main ledger. So the trust is maybe not quite as good. The privacy is maybe a little bit better. Performance can be very good. And if you have fairness at all, you could have fairness here. Although then the question is, well, how does the side ledger get its own fairness? And that would depend on what kind of consensus you're doing there. So maybe fairness is good, maybe it's bad. Then you have consensus service. Let's talk about the consensus service. This is a new thing that Hedera is doing. I'm just going to talk about how Hedera does it. This architecture diagram is very typical of any ledger, but let's talk about Hedera. That's the one that I'm familiar with. In the Hedera architecture, you have the mainnet consensus algorithm at the bottom, and it is ABFT secure. It has fairness, fair ordering, timestamps, and access. This is at the bottom. And then each of the computers that are running this are also running the services. And so we have the three services. They are doing the cryptocurrency service. You ask one of the nodes, please do a transfer of cryptocurrency for me. And all the nodes in the mainnet run that. Or you do a smart contract service. You ask it to run a smart contract. They all run it and they tell you the answer. Or you have a file service. You can store files. And you have that sort of thing that we do. And then on top of that, we also have sort of two implied services. Timestamping, because we do have the fair timestamps, and everything gets a timestamp on it. It's as if we were doing a cryptographic timestamping service. That's sort of like a fourth service. And a revocation service. When you store files, the file might be the hash of your driver's license. We have it where two keys are used, two signatures to put the driver's license hash there, but either of the key by itself can take it back out. So you and the authority can agree to put a hash of your credential there, but if it ever is revoked, the authority can revoke it without your permission. Or you can revoke it without the authority's permission. So it's a revocation service. Those are sort of implied services, but really there's the three main services. Those two are just implied. Then, of course, the purpose of the smart contract is that you can run applications on top of it. You write smart contracts. That's what these three circles are. They run on top of the smart contract. It is easy to deploy, easy to run. It's much slower than a native service. So the central struggle is always, how much do we take from this layer and move into our underlying service? Like, say, non-fungible tokens, NFT. Should we have our NFT inside a smart contract where it's slower? Or should we put it down as a native service to be faster? And you could ask that about many other services. What services do we want to make fast at the native layer, and what do we just leave in a smart contract, which is much slower? What we have decided to do is add a fourth service called the consensus service. It also has applications built on top of it, those three squares. But these run at the speed of a native service. It's as if you can build more native services yourself. If you think non-fungible tokens should be at the bottom layer, you can do that. Or if you want a stable coin to be at the bottom layer, you can do that. Faster than a smart contract. Because this consensus service is giving you access to the raw consensus engine underneath. It allows you to write your own. You have to stand up a network of computers, an AppNet, sort of like a side chain, but different. But you get the raw speed of the underlying service. So here's how it works. Now you have your mainnet. You have Alice, Bob, and Carol standing up an application network, an AppNet. And the single source of truth is with them, not on the mainnet. Which means you can have total privacy of these balances. You want a stable coin with total privacy. You want NFT with total privacy. You want a game that is being played in total privacy. It's in the AppNet. Complete privacy there. It does not store it on the mainnet. Then, when Alice wants to transfer her stable coin to Bob or wants to make a move in the game and tell Bob about it, she doesn't tell Bob, she tells the mainnet. All of the transactions that would happen in this AppNet flow through the mainnet, and you can encrypt them because the mainnet doesn't do the computation. The computers on the mainnet do not have to execute your transactions, they just put them in order. And once they have taken these encrypted transactions that the mainnet doesn't understand, the mainnet takes these transactions, puts them in consensus order, and then can send them back in order with timestamps on each one so you know when it happened, with fairness, if your mainnet has fairness like Hedera does, and with state proofs. So every 100 messages, every 1,000 messages, every 1,000,000 messages, it sends a state proof to prove that these messages were correct. They can be chained together with hashes, but it proves that they're in the right order that the mainnet agreed on. Once Bob has this, he can pass it on to Alice and Carol, and he can't lie because he has the proof from the mainnet that all those transactions are in the right order. But if he does that, then what that means is that Alice and Bob can trust it, not because they trust Bob, but because they trust the mainnet. If you trust that more than 2/3 of the stake of Hedera is trustworthy, then you trust this even if you don't trust Bob. Even if you don't trust anybody in the AppNet, only yourself, you still have trust. Privacy can be great. Your transactions can all be encrypted. No one knows what they are. The single source of truth, the state, is stored there. And trust is very good because it inherits trust from the mainnet. That's the consensus service. And it allows you to have performance because all the calculations are done on the AppNet, not on the mainnet. You have the great trust of the mainnet. It's like the trust of a public ledger with the speed and privacy of a private ledger. If you have an algorithm with fairness, like Hashgraph, then this has fairness. If you could run a stock market on your AppNet and it has fair ordering. When people put in bids, it puts the bids into a fair order. No one leader can put them in a different order. No one miner gets to choose in a block to put them in the wrong order. You have fairness of ordering and fairness of timestamps. And you can have great privacy. Without any other layers being built, you just have great privacy inherently as long as you encrypt your transactions. What would you use it for? Well, I mentioned stable coins. I mentioned a stock market. I mentioned games. You could use it for audit logs. If you send audit log messages encrypted for privacy, they come back in an order, and you could just store it with the proof that the order is correct and the timestamps are correct. And later, you could take it to an auditor and prove to an auditor that you did these things in this order. You would give the auditor the key to decrypt some of your transactions. So it can be used for audit logs with great privacy, great speed, and great trust. The trust doesn't depend on the AppNet. It only depends on the mainnet. So the concepts here, messages can be encrypted. They can be whatever kind of transaction makes sense on the AppNet. The mainnet doesn't have to understand it. You have great privacy inherently. You could send plain text if you want the world to watch. You can let the world watch. You can have transparency, or you can encrypt it. You could even just send hashes of your plain text. You could even encrypt it with short-term keys that are constantly changing for perfect forward secrecy, just like in SSL when you have perfect forward secrecy, TLS. That's what you can do. You can have mirror nodes. Hedera has mirror nodes that get everything happening on the mainnet sent to them, and they can audit it, and they can tell others. Bob could be a mirror node. You can have a running hash of these messages, so you don't need state proofs very often. So it can be very, very efficient. Very little overhead at all. That's because you have the state proofs, only occasionally, because the messages are chained. And you have topics. You can create on Hedera a topic, or you will soon. We will be rolling this out very soon after our open access. And you can create a topic, and then when you send messages to that topic, you can subscribe to just that topic and just get the messages from your topic. And the messages in one topic are chained together with a hash so that you know their order. So those are the concepts. How do you build the AppNet? The downside compared to a smart contract is you have to stand up computers. How would you do that? You could use people like AWS to stand it up for you. You could use things like Hyperledger Fabric to make it easy to stand it up and administer it. One member of our council, one of the shareholders, owners of Hedera, is IBM, which has been doing quite a bit of work on Hyperledger Fabric. And you can work with that. And so that is how you can get all of these properties and scale up. Thank you very much. I appreciate it. And now we have some time for questions. I think we have 8 minutes, if I understand it correctly.
Yes, right. So thank you, Dr. Baird. So now we'll have the time to answer the questions from the audience. Okay, so the first question is, I believe the blockchain is one of the cutting-edge technologies, and with existing technologies, the data can be reliable and can be set up. So is there any specialty compared to other technologies that blockchain itself is providing? And blockchain is not making impact on the society across. So is there any crucial reason for blockchain to open new era? And is the impact blockchain is making really different from that of internet? Since blockchain can be considered as a technology operated based on internet, so I believe only small impact can be made by blockchain. So what do you think about it?
Oh, do I think blockchain is not very useful? Actually, I think blockchain is useful. And I do have a question. My timer went up to 16 minutes. Do I have 16 minutes for questions, or is that a mistake? Probably
Maybe
not.
You can, no, maybe not. Maybe
Probably when this gets to 10 minutes, I stop. Is that right?
10 minutes?
I will assume when that counts down to 10, I will stop.
Maybe you can shorten.
Okay, so maybe someone can tell me when to stop this. Or just tell me to leave when you're tired of me talking. I think blockchain ledgers, DLTs, can really be revolutionary. There are lots of people saying it, and we haven't seen the revolution yet. Why not? It's still early days. We are just at the beginning of this revolution. The internet was around for a long time before it transformed society. DLTs, ledgers, are a layer above the internet, and they're going to change society in a lot fewer years than it took the internet to do so. And I do think that it will interoperate with all the other exciting things going on. There was a slide right before me that showed IoT and AI connecting to blockchain. I think that DLTs have the potential to interoperate with all the other things that are changing society right now, including IoT, Internet of Things, and including AI, artificial intelligence. So I do think that ledgers are about to become a very big deal. And I think that we are seeing the financial industry starting to really look at doing real things with asset tokenization and with transfer of value. And I think that we're seeing people using it for recording things, like recording histories of pharmaceuticals and diamonds and things like that, or recording ownership of land or of valuable properties. I think that we're going to see it being used even in things like games to create worlds that are more trustworthy and that even the company running the game can't corrupt the world. We have just seen the beginning. We haven't seen anything yet.
Okay, thank you. And there's another question. Who is making consensus service, and how can we rely on the consensus service?
Yes. So Hedera will be offering the consensus service. Right now we have the three services: cryptocurrency, smart contracts, files. We have optimized across the board to make cryptocurrency very, very fast. We haven't optimized for smart contracts or files. We will be rolling out the consensus service. We have a beta version of it running right now. We'll be rolling out the real version soon. And we have optimized for it to be very fast. So we're starting at 10,000 transactions per second and going up rapidly from there. It's the cryptocurrency and the consensus service that we want to be very fast. I think smart contracts are nice. We support them. But we're not putting much effort into making those fast. I think the consensus service gives you better privacy and better performance inherently because it runs at the native speeds. So we will be emphasizing that. So that's what we'll be doing in the very near future.
Okay, thank you very much. And the third question is,
Good question.
okay. I wonder what is difference between the blockchain and other technology.
Okay.
No, which has the anchoring technology to the upper chain, which is reliable and have a fame like Ethereum and Bitcoin?
The question is, I apologize, I'm not entirely sure. The relationship of blockchain to other technologies that aren't blockchain?
Sorry. So what is difference between the technology you have mentioned and the Ethereum and Bitcoin, which is reliable and have a fame?
Thank you very much. Yes. So Hedera is a DLT, just like Ethereum is a DLT and Bitcoin is a DLT. Bitcoin, of course, is only doing the cryptocurrency natively, but Ethereum does that plus the smart contracts, and Hedera does those, plus it will be doing HCS as well. But they're all DLTs, and there's some differences, like are they ABFT or not? Do they have fairness or not? And what kind of speed do you have in the mainnet? Those are some of the differences in the technologies. But yes, they're all DLTs.
Okay. And the next question is, what's the difference between Hyperledger Fabric and Hashgraph?
Good question. Wow, words are so confusing. So, Hashgraph is a consensus algorithm. It's an algorithm for computers to put things in order. Hedera is a public ledger that uses the Hashgraph algorithm to put things into order. So Hedera is like Ethereum or like Bitcoin. It is the ledger that is using Hashgraph as its algorithm. It isn't using a proof of work algorithm, it's using a proof of stake algorithm, it's using Hashgraph. Went away. So those are the public ledgers. Then there's a question, if you wanted to build your own private ledger, how would you do it? Well, you have to create computers and put programs on them and have them talk to each other and manage them. Hyperledger is a collection of technologies for doing that. For getting a group of computers together to talk to each other, you could use it for a private ledger. You could maybe use it for a public ledger, but it's a toolbox for building ledgers. Fabric is the part of that toolbox that is best at this bottom layer of getting the computers communicating with each other and talking to each other, and it calls a consensus, an ordering service to put things in order. Fabric with Hashgraph and Hedera, I should say, built in or plugged into it, then uses Fabric and Hyperledger to manage the computers in your AppNet. but Hedera consensus service to put your transactions in order. So it's a way to glue it all together. That's what it is. And we have plugins for Hyperledger that allow you to do this, for Fabric that allow you to do this, and so then they work together in that way. How am I on time?
Maybe 11 minutes will be left. So there is another question for you.
Okay.
The next question is, the consensus service is collecting transaction messages and making an ordering. So how can you know who we need to send the order of the transactions and which transactions should be sent? And if all ordering data is broadcast, isn't it too inefficient?
To start with the last one, no, it's very fast and very efficient. So the consensus, we're going to start by slowing it down to 10,000 per second, but we will be making it go up very fast from there. So it can be extremely fast. Finality is a few seconds. Not just the first confirmation, but actual finality where you're guaranteed is just a few seconds. The state proofs aren't needed on every message. You have this whole stream of messages that has consensus on their order, and periodically you can check that it's the truth by getting a state proof. You could do that once a minute, once an hour, once a day. So it's extremely efficient in bandwidth, in throughput, and in latency. That is how the consensus will be plugging into your AppNet and helping your AppNet. And then you had also asked the first half of the question. I forgot what it was. I apologize.
The consensus service is collecting the transaction messages and making an ordering. So how can we know who we need to send the order of the transactions and which transactions should be sent?
Yes, thank you. You can send a message. Anyone in the AppNet or even any user of the AppNet can send their message encrypted, maybe. If you want privacy, you would encrypt it. You send your encrypted transaction to any node in the mainnet, any node in Hedera. And then that node gossips it to everyone else, and they get consensus on it within a few seconds. If you don't trust a node, you can send it to a different node. If you don't trust any single node, you can send your transaction to 2 different nodes at once. And whichever one reaches consensus first, that one counts, and the other one will ignore your message. So you could send it to 10 nodes, and if even one of them is honest, your message gets out fast. You only need one of them to be honest. There's no downside. You pay a small amount for each one you send, so if you send it to 10, it costs 10 times as much, but it's 10 times a small amount. But if you want huge reliability, you can do that, and you don't have to trust any one node, which is why we talk about fairness of access because of that.
Okay.
Thank you.
Thank you very much, Dr. Baird.